Now. So guys, I am super excited and happy to be here. Thank you so much for tuning in to another one of our presentations. If you've been to some other of my presentations, thank you very much for being here again. Hopefully you're not tired of hearing my voice. I post a lot on LinkedIn, put a bunch of videos out. But yeah, showing that you're here means a lot to me. So what we're gonna do today, we're gonna keep it a little bit more casual than we normally do. So it's not gonna be a full-on presentation about acoustics 101 and how acoustics work and that type of deal. What we're gonna do is we're really gonna go in depth and look at a particular project that we did last year, which was 283 Greene Avenue. So for anybody and everybody who's interested in mass timber and that wants to know more about it, well, this is it. So hopefully I'm able to convey some brand new information to you guys. Hopefully the content that I put in and the efforts that I put in are going to be helpful for your future projects or the projects that you're working on right now. So there's still some people logging in, but without further ado, guys, I'm going to get started. So I'm going to be sharing my screen right now, which I noticed I haven't done yet. Perfect. So guys, what we're gonna do right now is we're gonna start the presentation and we're gonna talk about mass timber sound control at 283 Greene Avenue. So let's get things going. So how did this all come about, guys? So everything came about after the release of a case study. The case study we did on the 283 Greene Avenue just before the holidays. We released this case study in collaboration with many stakeholders that participated in the project, like the developer, the acoustical engineers, the installers, and even the manufacturers of the CLT panels. So after we released that case study, there were a lot of questions coming our way, about the results, about the installation, about how all that came about, the wall assemblies, the floor assemblies. So there was clearly a lot of interest coming our way as to, how this project happened, maybe the challenges that we face. So that's why we thought, hey, why not do a webinar style presentation where we really go deep and talk about exactly what had to be done at this project so we get a good acoustical result. So what we will do is we're going to discuss how we efficiently control sound levels in this residential building, what challenges we faced, and why we think mass timber has a bright future. You will also be able to get really good insight from the flooring contractor, the CLT manufacturer, the acoustical engineers, and the developer through some video interviews. So we conducted a series of interviews before the holidays last year, which were awesome. I think people really, really liked those interviews. Now, I'm not going to share the full interviews during this presentation because it wouldn't make sense. We don't have 3 hours of time. But what we have done is we have compressed the absolute most important information on each and every single one of those interviews, and I'm going to be presenting those to you today. So hopefully you like them. So there's going to be 5 topics of discussion today, guys. So first of all, we're going to talk about the challenges. We're going to talk about the building. We're going to talk about the solutions. Then we're going to go through the results, and then we're going to go through the tests and studies. Okay. So first of all, let's take a look here what we have. So the challenges. First of all, one of the challenges was the fact that we had exposed ceilings, okay? Second challenge that we had was the fact that there were no wet trades. Of course, this building probably presented some other challenges for the developer or the architects, but I'm sharing information here that I personally had experience with, which obviously was the acoustic side of things, which is a pretty important part when talking about mass timber projects. But that's what I'm going to be sharing with you today. So first of all, when it comes to the exposed ceilings, at the very, very beginning, when I got introduced to the project by the architects, which was Loading Dock 5, it was clear right off the bat that they did not want to have suspended ceilings. They wanted to have those ceilings exposed, obviously because it's a beautiful product. You have the wood exposed. it reacts as your finished material, and it gives warmth to the places. And it's super trendy right now, of course. So it did not make sense for them to use a suspended ceiling. Now, from an acoustical point of view, that creates a little bit of a challenge because we are removing one area that cannot be used to create airspace and additional mass through the drywall to have a better acoustical rating. So right off the bat, we had to remove that out of the equation. So if we couldn't work through the ceiling, we really had to be creative. So we had to be creative and find other ways to create that airspace and that additional mass. So obviously, if we can't work from below, we had no choice but to work from above. Another thing that was very, very clear from the beginning was that they did not want to use wet trades. And I don't think it was necessarily a personal choice at the very beginning. When I got introduced to the project, which was not at the very beginning, unfortunately, I was introduced to it a little bit later down the road. What the architect had expressed to me was that there were no contractors in Brooklyn that wanted to pour a concrete topping in this building. I am still not sure exactly the reasons why. Was it because the contractors were not used to using these types of toppings? Maybe they were a little bit scared of having maybe a failure of some type because, you know, mass timber was brand new to them. But the bottom line was that they could not find somebody that would do the job. And as they, you know, dig more into it, they found out that maybe there were some other alternatives that could bring, you know, good value to their project without having to deal with wet trades. Some of them, you know, they looked into the weight that it was adding to the building. They thought, you know what, by not using a wet trade, it significantly reduces the weight of the building. Also, the humidity control, the drying time that we need to take care of when using wet trades, and obviously overall, just the additional delay that it brings and this lower production was not very appealing to them. Personally, we do not have anything against wet trades or against concrete toppings. If they would have wanted to take that route of using a concrete topping, we would have been able to guide them through that and help them select solutions that were made for concrete toppings. However, they did not want to use this type of solution. And most importantly, after many, many years of studies with wet trades, we know for a fact that in a mass timber building that does not have a suspended ceiling, it is extremely hard and almost not possible to reach code minimums. So 50 IIC and 50 STC. It was very difficult to go and reach those numbers without a suspended ceiling and a wet trade. So even if we would have proposed something, we would have had to say from the very beginning, hey guys, you know what? It is very likely that you do not hit the numbers you want to hit with a wet trade. So right off the bat, we knew we needed to go with something else than a concrete topping and a resilient material. So what I'll do right now, guys, is that I'll show you the interview that we did with Ali Verity. So Ali Verity is from CV Partners, and they're the developers rep. We were working very closely with her, and she's going to talk about the learning curve and how it was to work with a mass timber building for the very first time. She's probably going to share with us as well on that video some of the challenges that she faced and, you know, how she sees the future of mass timber as a whole. So I'm going to go ahead and play that right now.
So my name's Ali Verity. I am one of two partners at CV Partners. My partner, Sarah Carter, is on my team as well. And we are the owner's rep for the developer of this project. So we work hand in hand with them, really from identifying the building to identifying consultants and now through a very long construction period. And it was until we had no idea what heavy timber was, and we had our first meeting with Loading.5 and told them we want this to be a very environmentally conscious building, ideally zero footprint, which we're trying to zero carbon footprint if we can. And they were like, you know what, there's this really cool material that's used everywhere, not in New York yet, but it's
Yeah.
heavy timber. We really like cross laminated timber. And we all just kind of like fell in love with that idea, and we really went from there. Obviously, we very much like this product, and we're already in development on another heavy timber, cross laminated timber building. So I hope they keep building with it. Obviously, we love working with them, and we've built a good team on this one. And I think, as with any new technology, if you're the first one to do it, it takes longer, it costs more, people learn on your dime, but it becomes really effective and efficient if you take that and you replicate it, because then
Right.
you know the errors, you know what to look for. And obviously the second one's going to have mistakes too, and things that we could have improved upon, but hopefully if you have a team and you keep doing this, you you get to do it very efficiently, and you can build a brand out of it. In terms of working with the product, I think it's pretty easy to work with. It was constructed, this building is 5 stories. It went up in, I think the whole structure went up in like 11 or 12 days. And that's unheard of with concrete, right? It needs to cure, and it takes all of this additional effort. So that in itself was easy to work with. And then obviously, we pre-coordinated where we had risers and things throughout the building. But if you had to cut something new, you're not pouring concrete, you're just cutting out a piece of wood. So it was a pleasure to work with. It has its challenges. We ran into some issues on this project just with our initial contractor. We had some issues with, and then also just the novelty of the product, the novelty of using Nodora concrete, insulated concrete as our exterior walls, all of these things that are learning curves. I mean, I would say the the cost and the speed of it, right? The cost, it's a little difficult for us to compare on this project just because, as I mentioned, it's been going on for quite some time. We had several hurdles. It's kind of hard to quantify.
Yeah.
But assuming this next one that we do goes without those initial problems we had, I think it's going to go very quickly.
Hmm.
And time is money in development, right? You're sitting on a property you bought, you're paying consultants, you're paying like it all adds up. And I think that just having seen the structure go up so quickly, and now that we are going to make some changes on the exterior wall, I think you can really pitch it to people like it's beautiful. You save on interior finishes because your structure is your exposed ceiling. It's part of your exposed walls if you want it to be, and it's fast and it's
Yeah.
sustainable. So it's, you can have a, clear conscience building with it. So building code was difficult, right? We filed the Department of Buildings. We filed, it's called a CCD1. It's a consideration in order to get your drawings approved. We received the approval, and then call it halfway through construction when we had a nearly enclosed building. I think the Department of Buildings was like, whoa, 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 how did this get approved? And we went through an audit. So that was it stopped work at the site for a little bit. It did take some time. It was, a couple months of uncertainty. So I would say that that was one of the bigger delays. And then also just the unfamiliarity of working with the product. I mentioned we had putting the failed contractor aside. It's a learning curve.
Yeah.
So working with concrete has its drawbacks. Obviously, working with CLT, it's like Lincoln logs. So everything has to be, you plan it ahead of time, and everything needs to be ready to reserve what was already planned and what
Absolutely.
arrives on site. So I'd say the challenge was just like your basic, you know, developing a learning curve, and then
Right.
also permitting challenges. But the city was great. They worked with us through it. We had several meetings about it. We agreed on what we could do to ensure that they felt safe about what we were building. We beefed up those systems, and we're gonna have a really beautiful building. So, like you said, you don't have anything in the ceiling that's absorbing sound. A lot of the walls are either concrete, CLT, or some are sheetrock. It seems like you're going to have an echo chamber, but being in those spaces, it always surprises me how quiet they are. Every time I walk in, it's like you shut the door and it's nearly silent.
So there you have it, guys. That was the interview we had with Ali Verity. And like she said, it's all a learning curve. And from a developer point of view, of course, they're going to want to replicate it. They're looking forward to working with Massimo again, which is a great sign that they had a good experience with it despite those challenges. And all they need to do is learn from past experiences, past mistakes, and hopefully they can build a brand, which definitely says a lot and it looks very bright. So let's keep going here, guys. So let's then talk about the building, okay? So we're gonna talk about the floor assembly, the wall assembly, and afterwards we're gonna see the interview with Nordic Structures. Now, of course, I would have liked to go more in depth into the whole building aspect of things, but first, we don't have enough time for it. And secondly, I was not personally involved with the whole building. I was then again involved with the acoustic side of things, which was primarily in the floor assembly and the wall assembly, which is what I'm going to talk about. So after having many conversations with Loading Dock 5 and understanding that they did not want to have a suspended ceiling, they did not want to deal with wet trades as well, we took this to our technical team and we started, throwing around some ideas, taking a look at what would work, what would make sense for this project, especially because this was not just some commercial project where there was no particular needs in terms of acoustics. This was a residential building on an up and coming area in Brooklyn that was going to be high end. Even if it's apartment rentals, they were going to be high end apartment rentals. So it comes with expectations. So what that means is that we needed to absolutely meet code, but most likely exceed code. So that was what we were shooting for. So through the many years of R&D that we did, we took a look at all the assemblies that we had experienced with, and we came up with this assembly right here that we proposed to Loading Dock 5, which were the architects in this project. So I'm going to explain it to you from top to bottom. Obviously, I'm going to go more in detail on the solutions that we use a little bit further down the presentation. But for now, I want you guys just to understand the assembly that we had all together. So first of all, we were dealing with a tongue and groove wood flooring that was installed over 2 layers of plywood. Okay, so a 1/2-inch plywood, a 5/8 thick plywood. Afterwards, we had our Sofix panels, which I'm going to explain in detail afterwards, but just for you to know, these are panels that are going to be made out of mineral fibers and plastic cups. Right underneath that, we have a layer of synthetic fibers that are needle punched, and it's called Acoustic Lead 6. So this is about 1/4 of an inch or 6 millimeters thick. And then obviously we have our CLT panels, which was 8 3/4 of an inch thick, so 220 millimeters. And we're talking about a 7-ply CLT, okay? So all in all together, we're talking about an assembly that has a total thickness of around 11 inches and 5/8. Now, of course, since the architects did not want to deal with a wet trade, did not want to deal with a suspended ceiling, we had to be a lot more creative with what we used on top. So the solution had to be a lot more robust, okay? We couldn't necessarily say, hey, you know what, let's just slap this underlayment on top, put this type of flooring, and cross our fingers and hope we reach code. It doesn't work that way. We had to be working with something completely different than just an underlayment and a flooring. So this is the assembly we proposed. When it comes to the wall assembly, now, one thing that I do want to point out, the reason why I'm speaking about the wall assembly is because with the acoustical engineers, we did test the wall assembly. And I'm going to talk about the results that we got a little bit later. However, we had no say whatsoever in the wall component. We did not provide any solutions for the wall component whatsoever. So this was directly a detail that came from the architects. It did not come from us. So that being said, I still want to tell you what we had as far as composition, and I'm going to talk about the results a little bit later. So From left to right, what we had was 2 layers of type X gypsum boards. We had an 1.5 inch deep metal stud that was filled with 2 inches of bad insulation. We had about 1/4 of an inch of space that was just airspace. And of course, afterwards, we had our CLT wall that was also 220 millimeters, 7-ply CLT. All in all, for a total of a wall assembly that is going to be 11 inches and 3/4. Now, what I'd like to show you was the awesome interview I had the chance to do with Simon Gallagher, which was the project manager for the Greene Avenue project. He's going to explain to us the tasks that he had on the project, maybe how this project was different from everything else that he did, and some of the reasons why you should plan ahead with your team when you're building a mass timber structure. Let's go.
So I'm a structural engineer. I've been with Nordic now for almost 10 years. So I started as a structural engineer and now I'm a project manager and team lead. In the Greene project, I was the project manager for the Nordic side of things on that project. The connection design for this. So design assist. So we looked really at all the details and tried to optimize where we could. Tried to things that made more sense for the fabrication side of things. The constraints that the shop has to try and fiddle details to make them work a bit better. And then really all the design of the mass timber connection. So how does the mass timber attach to itself and to the concrete and to the foundation, and designing all those, calcing all those, signing them, and producing shop drawings so that the install team can follow something so that they know what to do on site. The install sequence with that balcony that's hanging off the concrete wall, and also just the sequencing too between the wood and the concrete, the side concrete walls, the way that it all came together. Actually, the CLT slab is supported by the concrete, and the concrete wasn't there. It came afterwards.
Yeah.
So there was a whole sequencing issue there that was something to work around. The impact that the spaces create. So if you leave that wood exposed, it's just a beautiful finish, and it's also a finished product right away. So you don't need to come back and apply a whole bunch of things. Your structure is your finished architectural product. So that's another huge advantage, and just the quality of life for the people using the building is a lot nicer. And the last one from an economical, let's say, standpoint is the speed of installation. So wood building will go up much more quickly than a concrete counterpart. I can think of a whole bunch of buildings that just pieces just fly into place. It's like a Lego set, right? It's like a Lego set, and you have your truck and you just drop your pieces and you just slowly build your way up, and you're putting up floors in matters of days, as opposed to concrete where you need your shoring, and then you need to build your formwork, and you pour it, and you need to wait 7 days, and you keep going up, and it takes quite a bit of time. That speed is a huge savings. So you decrease the amount of time on site, so you save on crane, labor, and you get your building a little bit faster, so you can capitalize on that a little bit sooner. Yeah. I think it will be more cost effective if it's planned properly.
Mm-hmm.
If people like the manufacturer are involved early,
Yeah.
if the other trade like plumbing, electrical, all the HVAC, all that stuff,
Yep.
if those people are involved early in the process so that they can really coordinate everything, then yes, then you get those savings. Because people are used to building with concrete, so they know how, they know how it goes. They can come in
Yes.
kind of late and just they do the same thing that they've always been used to doing. Here, there's a little bit of a learning curve, and if everybody's involved early, then there's no question that that there's a huge saving on speed on site. Yeah. Honestly, it's growing like crazy. There's a lot more demand. Everybody, you know, competitors, ourselves, we're all there's more and more production, so the capacities are increasing. There's a huge growth in the market. I feel like over the last 5 years, there's really been a lot more interest in, especially in the United States, that's driving a lot of it because it's a huge market. And I would say, yeah, over the last 5 years, there's been that growth, that interest, people developing new tools, techniques, things that can be applied to mass timber. I think right now is a great time to be in the industry. I think there's a huge future, definitely. Yeah.
So there you have it, guys. That was the interview with Simon Gallagher. And I think it was very interesting, some of the things that he shared about mass timber reacting as your finished product, which you can really pitch to people. I think that was very cool. Also, the fact that if you involve your team very early in the project, the earlier the better. How a mass timber project doesn't necessarily mean more expensive or more issues or challenges. If you get involved early, it can definitely speed up the whole process and can actually be more cost effective than maybe a concrete counterpart. So moving on, ladies and gentlemen, I have a volume up here. Perfect. Okay, so now we're going to talk about the solutions. Okay, so we're going to take a look at the flooring detail that was selected by the architects. We're going to talk about the materials that were used. And of course, it's the right time to show you the interview that we did with the flooring contractor, which was City Interior NYC. He's going to share with us some of his comments regarding the installation of the product. So the floor detail is exactly this. So this was what was selected by the architects to be used for the project at the very end. So we're going to have our wood floor that is going to be tongue and groove. We're going to have our 2 layers of plywood. We're going to have our Acoustitek suffix. We're going to have our LEED 6 underlayment. And of course, we have our cross-laminated timber. One thing that I do want to point out here, guys, is that if there was a need to swap the plywood panels by maybe an OSB, for those that are wondering, that could have been possible. Sometimes for projects that are a little bit more price sensitive, they're looking to save a little bit of money, using OSB instead of plywood can be done as well. Now, another thing that could have also been done is using the Sofix panels by themselves. However, there was a risk there because the underlayment, the LEED 6, its whole purpose was to help us be as high as we possibly could in terms of impact, which takes me to the next slide that we have right here. So these are the 2 materials that we used on Greene Avenue. So first of all, I want to talk about the LEED 6. So this is a synthetic fiber underlayment that we manufacture. It's actually manufactured in Quebec, in Laval, which is close to Montreal. And this is not just your run-of-the-mill underlayment that we see very often in New York. For example, a rubber type underlayment or a foam underlayment or even a cork type underlayment. This is pretty much engineering inside an underlayment because we're talking about something that is made out of synthetic fibers that are needle punched. So this is a very effective product when it comes to absorbing impact sounds. So that was the whole purpose. The solutions that we have here, their main purpose is to help with acoustics overall, but the LEED 6 really had as a mission to help increase the performance when it comes to impact noises, okay? Now, when it comes to the Sofix panels, these are panels that are about 2 by 4. They're extremely lightweight and very easy to work with because it's not a wet tray. It's not something that is glued down or that is nailed down. They're simply floated on top of the LEED 6. So we have our CLT panel. We have our layer of LEED 6 that is applied on top. These come in rolls that are 150 square feet per roll. They're about 16 pounds per roll, which is extremely lightweight if you're comparing to, let's say, a rubber type underlayment that is 5 millimeters that can weigh around 90 to 100 pounds. People carrying this around definitely appreciate a product that is lightweight. The SOFIX panels are about 4 pounds per panel, which is extremely light. So they're completely floated on top of the lead 6. And afterwards, we lay down our 2 layers of plywood over top. And afterwards, it becomes a solution that is very acceptable for any type of floor covering. So we can use a nailed floor over top, a glued floor, a vinyl, ceramic tile. Any type of flooring can be used on top of this. Also, when it comes to the SOFIX panel, I want to explain a couple of things. So we're talking about a material that is made out of mineral fibers in combination with blue cups. So the blue cups underneath also are very, very particular. So this was something that was actually developed by our technical team through a lot of R&D, months and months of R&D, because we understood from the very beginning when we got involved with mass timber construction, we understood that there was a big need of having a solution that did not involve a suspended ceiling. We saw that right off the bat. So we understood that we needed to create some airspace over the CLT since we couldn't create that airspace underneath. So what we had to do is create something that provided that airspace, but at the same time that provided that stability, that mechanical stability for the whole floor that was going to be applied on top. So that's why a combination of mineral fibers with extremely, extremely strong cups underneath made a lot of sense. Now, the distance between the cups in the panels was extremely important. If they were too close together, we didn't get a good result. If they're too far apart, we didn't get a good result, or we were having some issues with mechanical weight load and resistance. So by having them spaced at the right distance, we came up with a solution that was very, very effective in terms of acoustics and in terms of mechanical as well. So the weight load that these cups can support is extremely high. We're talking around 500 pounds per square foot, which is extremely high. So we needed to do this because at the end, we don't really know what clients are going to do, with their flooring. Are they going to put a very heavy piano on top, a very heavy piece of furniture, for example? These panels are also to be used in gym situations, basketball court, where there's going to be extreme amounts of impact on the surface of the floor, weightlifting rooms. So it is very versatile when it comes to its uses. So both of these products were used at the Greene Avenue project together in order to achieve those good levels of STC and IIC. Now, when it comes to the installation and actually using the material, I thought it was a very good idea to have an interview with Russ Bragg. So he is the was the contractor for the Greene Avenue project, and he's going to share with us his experience with the solutions, the installation of the products, maybe how different it was to work on a mass timber project compared to concrete buildings, which is normally what he does. So I'm going to show that interview to you right away.
It's definitely a lot different than working with a concrete substrate, where the standard in New York is you have a concrete substrate, which is then, you glue some sort of a rubber substrate to that, and you glue the wood flooring on top of that, and everything's even and fine and dandy. Here, it's a little bit more work than that, because the CLT is wood. It breathes, it moves, it changes dimensions. In the transportation process from Canada to New York, the CLT gained moisture, it lost moisture. While it was being set up, it gained moisture, it lost moisture, it was exposed to the environment. So you got to understand that when you're installing on top of it, it's not as clean cut as it is installing on top of concrete. You got to deal with the bumps, the bruises, the CLT parts that are coming up or out or expanding, and you have to understand what you can do on top of it. Now, your products that that we used on top of it were fantastic because they let the CLT be CLT. We didn't have to change the CLT too much because we had the right product to put on top of it, which allowed us to let the CLT breathe and expand and contract as it needs to. Now, some people don't know that they could do that, and rather, than just putting the right product, they just may slap a piece of plywood on top and call it a day. That's a solution. It's probably not the best one, but it's a solution. We're against doing that because the noise will travel through the CLT and down into the lower and adjoining rooms and apartments, which is not what any architect or designer or developer wants, especially the developer, because then you're just going to have complaints from the tenants. The right thing to do is to use the right products and to do it right with the assumptions of letting the CLT be the CLT and noise transference with whatever product you're putting down. Well, the CLT had beams in certain spots, so we need to make sure when we install the soffits specifically that we avoid those beams, right? Because the beam sits 1/4 inch, 3/8 higher off the rest of the CLT. I prep my team that anytime we're installing the soffits, make sure none of those balls, those blue balls, end up on the beam. They have to be off the beam at all times. And actually, the way your soffix is installed, the distance in between the balls is slightly larger than the beam, which worked out fine. We followed that, and that's why we made sure all the CLT soffit, the balls were at every entry point, because it was important that it doesn't dip any entry point or exit point or door or anything like that. The balls had to be lined up on the edge to make sure it doesn't dip when you step into the floor.
Yep.
Right? Because if you have a dead spot where you're coming in and out of somewhere, you're gonna feel it. But I made sure my teams were installing it that we made sure there's balls at all exit points, exit and entry points, bathrooms, laundry rooms, bedrooms, entry to the apartment. That was important. I think because this being the first building and having the certain nuances that we had of it being the first, this might have taken a little bit longer. I think going forward, our installation time of the whole entire building, not just my trade, but all the trades together, should be 20 to 30% faster. The first, for any contractor, things require thought and patience and time before you just jump in and do what you need to do, which a lot of contractors like to do. They want to get in and get out. This wasn't that project. You have to take your time. You got to do things right. You got to do things correctly, precisely. You can't have mistakes because there's no going back from it. So I think the next building that's going to be coming up, which is also, I believe, a frame concept, will be a lot faster. It will go a lot smoother, and we're going to have a lot of ease from the local building department, who was also responsible for some of the delays, because they have never seen a structure like this. Even though this frame CLT structures exist all around the world for hundreds of years in Europe and for many years in Canada, it just hasn't taken effect in New York. And so people are very weary as to how to deal with it, how to assess it, how to approve it, and how to let contractors do what they need to do to make, to get this building finished. So I'm looking into it. I think it's a cool concept. I think it's very modern. It's very environmentally friendly. I think it can be put together quicker than a regular structure. It's more like a puzzle pieces that just kind of connect, and boom, you have your existing structure. Things will turn around, and I think that will be a viable structure that people will follow. Definitely in Brooklyn, it will be a hit no matter what. I know Fred, the developer there, has planned several structures in the same style, and I think he's going to do very well with it.
So guys, there you have it. That was the interview with Russ Bragg from City Interior NYC. I thought he shared very cool insight about how you just need to let the CLT be CLT, because it has its own particular needs. And once you wrap your head around that, I remember the guys on site at the very beginning, they were a little bit thrown off by the fact that it was so different. So obviously, I personally did a lot of visits on site. I was working with the guys, talking to them about the installation, how it had to be done. And at the very beginning, learning curve, of course, but afterwards, they were moving along very, very quickly. So like Russ said, once you wrap your head around it, it can become very, very quick. There's a learning curve, of course, but as with anything, it's just a project that you don't have to expect that you're going to get in and get out as many contractors do sometimes. So I think it was a very successful installation because after seeing the acoustical results, which I'm going to show you in a few minutes, it just showed that the installation went very well because, of course, we can create solutions that are very performant. We can create, very good detailed installation documents. We can be on site and talk to the guys and tell them, hey, you should be doing this and take a look, you should pay attention to this. But at the end, we're not there every day. We cannot hold them by the hand and make sure they're doing everything as we expect them to. That's just not realistic. So I never received really any phone calls. Whenever I'm receiving several phone calls from a contractor, it means that they're having trouble. So I literally had a phone call with Russ at the very beginning of the project, and I had a phone call with him when the project ended. Obviously, in between, there were some site visits, but that was it. So it shows that the installation process went along very, very smoothly. So to keep things going, guys, we're going to now talk about the results. So we're going to talk about the area that was tested. We're going to talk about what kind of test was done. We're going to take a look at the ratings, at the results that we had. And obviously, we're going to take a look at the interview that we had with the acoustical engineers, which were AKRF in this case. So as far as the area goes, so what we did is that we tested 2 separate master bedrooms, one that was in the middle part of the building and one that was in a corner unit. The reason why we created the exact same tests on both of these units was simply because we need to make sure that the results are going to be consistently the same. If we would have gotten a result in one area very different from another, we would have known right away that there was an issue, whether it was an installation issue, whether it was maybe some flanking, some alternative paths where energy is traveling. So that's why we said, hey, you know what? Let's test not just one unit, let's test 2 and see if everything is consistent. Also, as you're going to take a look at the middle here, we're going to see the wall that was tested as well. So we tested everything from the 4th floor down to the 3rd floor in a middle unit and in a corner unit, as well as the wall in between both of them. So when it comes to the test, guys, what was used, of course, and you're going to see that in the interview as well, we used a tapping machine that has a bunch of hammers underneath, and a speaker was used as well. Now, I was not particularly involved with the testing. This was completely done by AKRF, which is a third-party acoustical engineering firm in New York City. They were the ones in charge of the whole testing of things. I was not present. They were doing all of this by themselves, and at the interview, they got to share some really cool comments of what they thought about the testing as well. So when it comes to the actual test, I think it's a good idea for me to go quickly over some principles about the 2 ratings that I'm going to talk about. I can take into account that all of you guys have seen my previous presentations or that are super familiar with what an STC code is or an IIC code is. So I'm just going to quickly go over those 2. So first of all, the STC ratings. Okay, so what does STC stand for? STC stands for Sound Transmission Class. Okay, and what does that mean? It means that these are all airborne noises. So a speaker playing music, for example, a dog barking, somebody having a conversation, somebody watching television, everything that involves sound traveling through the air are airborne noises. Okay, now how do we test airborne noises. So we're going to have a speaker, like you saw in the little video just before. We're going to have a speaker in one room, which in this case was the fourth floor master bedroom. And right below, on the third level, we had a microphone picking up on those noises that that speaker created. Afterwards, we do a bunch of calculations, and that's how we get an STC result. So, building code. What does the building code require in New York City? So the minimum requirement for STC was 50, okay? Now, there is also another type of rating, which we call AIIC. We simply added an A before the STC, okay? So building code also requests a rating on ASTC. So ASTC requirements is 47. Now, I want to mix you guys up, but here, what is the difference between an STC rating and an ASTC rating? The only difference between both is that an STC rating is normally tested in a laboratory, which means controlled environment, great installation, and not a lot of alternative paths of where sound can travel. So it's just a direct path that is being measured. ASTC stands for apparent sound transmission class, which means that these tests were done in the field, which means that they are a lot more realistic or close to what we could have in real life because they're done in the field, okay? So just keep that in mind. The difference between two is just that one is done in a laboratory and one is done in the field. That's the only difference. So if we go and take a look at the results that we got in this project. So as I said before, we tested 2 separate bedrooms going from the 4th floor down to the 3rd floor, as well as the wall assembly. So if we take a look at the very first column right here, okay, from the 4th floor master bedroom going to the receive room, which is the 3rd floor master bedroom, the result that we were able to obtain was an ASTC of 57. Now, if you remember what I mentioned just before, ASTC simply means that this test was conducted in the field and not in a laboratory, meaning that we are under an environment that is a lot more realistic, of course, because we're in the actual building and where we're not controlling windows, we're not controlling doors, and we're not controlling alternative paths of where sound can travel, which means an ASTC result is a lot more realistic than an STC result, okay? So in this case, we got a 57. Remember, building code requirement for an ASTC is 50, okay? And we got a 57. So a lot higher than what is required by building code, which was amazing news, of course. Afterwards, we tested the corner unit from the 4th floor down to the 3rd floor. Now, what result did we get on airborne noises there? We got a 56, which to us shows us that there was in fact a consistency between both units. Now you're going to say, well, how come is that? You know, there's a 1-point difference. Well, in acoustics, 1 to 2 points difference pretty much tells us that we're getting the same result, because 1 or 2 point difference pretty much is negligible, okay? To the human ear, you could never tell that this unit is performing at 57 and that unit is performing at 56. You start noticing a difference to the human ear around 3 to 5 points. 1 point, 2 point is not perceivable by the human ear, which means that in both areas that we tested, we could confirm that we were indeed getting the same results, 57 and 56, which were amazing. Now, when it comes to the wall assembly, there again, we did not have any involvement in that. However, there is a part that a floor assembly is going to play in the overall result, because we're talking about alternative paths of where sound can travel, so flanking. So we wanted to see if our flooring assembly had a good impact when it came to the wall assembly when it was being tested. So when the wall was being tested, also requirement by building code is to respect a rating of 50. In this case, we got above 50, so we got a 52 for the wall assembly, which meant, you know what, we're over the minimum required by building code, which means we're in a good position, and the flooring is working well with the wall assembly as well. So moving on. When it comes to impact noises, guys, so what are some examples of impact noises? Well, of course, having somebody walk on the floor, jump on the floor, like you see in that little video right there, somebody that is throwing something on the floor, moving furniture, for example, all these are examples of impact noises. Now, what you see in the image just below right there on the left side is how we perform a test for impact noises. So we're gonna have, like you saw in the video at the beginning, a tapping machine with a bunch of hammers underneath that in this case was on the 4th floor. And then with a microphone, we were measuring those impact noises with a microphone, okay? We did that in the 2 units from the 4th down to the 3rd floor. Now, what about requirements? What does the building code require in terms of IIC? So building code requirement asks for a 50 IIC to be respected. Now, for anybody that is present here in this presentation that is from Canada, you're going to notice that in Canada, there is no requirement for impact noises. There's no requirement for IIC. There is simply a recommendation for a 55. So recommended minimum is 55, but there is no requirement whatsoever. As in the US, there is a requirement to respect, and builders, developers, architects always make sure to pay good attention to that. Now, to anybody that is here from Canada, I do want to point out that even though there is no requirement by building code for IIC, if you're working on a project that is going to be residential, that is maybe going to be on the higher end of things, whether it's an apartment rental or a condo building, even though there is no requirement for impact, you need to absolutely make sure you're shooting for a mid-50s range, because most of the complaints that come in, and this comes from several years of working with the architects, several years of working with acoustical engineers, most of the complaints that come in when they pick up the phone are not necessarily about hearing their neighbors, talking or watching television. Most of the complaints that come in to these guys, to the acoustical engineers, are issues in regards to impact noises. People are complaining about, hey, I can hear kids running around. I can hear kids dropping their toys on the floor. I can hear, a lady with high heels, for example. So even though in Canada, there's no requirement for impact noises, please make sure that you're dealing with it, because at the end of the day, if an owner buys a condo or moves into their apartment rental building, they come with expectations, okay? If they're paying big bucks for it, especially, they come with expectations. And if they hear their neighbor all the time walking on top of them, they're gonna pick up the phone and call somebody to complain. They don't know what the requirement, the code requirements are. They don't know about the recommendations. They just know they're not comfortable in their home, and they're gonna pick up the phone and complain to somebody. And believe me, that's not a position you wanna be in. So when it comes to the results that we got at the Greene Avenue project, there again, obviously we didn't test the wall for impact noises. That just doesn't happen. We don't really do that. But we did test from the 4th to the 3rd floor, the 2 units on impact noises. So the first unit that we tested gave us a result of AIIC 53, which was great because we're not only meeting code, we're exceeding code, okay? Then the other unit just beside, we tested, gave us a result of 54, where there again, it shows us that we have consistency throughout the building because there's just 1 point difference. If we would have seen a difference in result, let's say we got a 54 in one unit and then a 49 or a 50 in another unit, that would have been a big red flag. There's issues maybe with flanking, there's issues maybe with the structure itself, or with the way the product was installed. But seeing a 1 point difference just shows us that everything was consistently performing throughout the building. So these results were great. We were very happy to see those numbers. So moving on, what we're gonna do now, guys, I'm gonna show you the little interview. This is the last interview that I'm gonna be showing you, but I think is one that is the most interesting to me, at least, because these guys talk about acoustics, they talk my language, and we're gonna talk with Matthew Manis and Nathaniel Fletcher. They're gonna share with us, the testings that they perform, the physics of what mass timber needs when it comes to acoustics, and why we should be aiming for a higher than just code minimum when building a mass timber structure. So I'm going to go ahead and play that to you guys right now.
When we set up our equipment, the impact test involves a tapper, and the airborne test predominantly involves utilizing a speaker with pink noise. We tested 2 floors in 2 separate master bedrooms. So those impact tests were from the 4th floor down to the 3rd floor.
Yeah.
And 1 airborne test between demising bedrooms, between 1 master bedroom to a smaller bedroom.
For the majority of our projects here in New York City, it's concrete reinforced concrete structures. But when we're talking about mass timber, it's, although massive, it is not nearly as massive as concrete.
Mm-hmm.
Physically speaking, it just doesn't have the same density. So acoustically, it presents some unique challenges. Aesthetically, it's beautiful, but if we don't want to slap some sheetrock on the underside of the mass timber for our ceilings, that means that we have to provide acoustical separation in other ways. And so the uniqueness about the Acoustitech product is that it creates an airspace and a cavity. It creates acoustical separation in terms of an isolation plane between the top side, the floor, and the bottom side, the mass timber itself. You can create the airspace on the top side or the bottom side. We often see it on the bottom side with the ceiling below, but the physics don't care. The physics just wants to see the airspace and the additional layer of mass above, which is exactly what we saw on the Greene Avenue project.
My advice would be, do not design and do not buy a unit that includes mass timber and it's designed to code minimum. Code minimum STC 50, IIC 50, that's a lab rating. And if tested, as you mentioned, 45 is acceptable. That is, that's practically IBC code, International Building Code, that's minimum. But if you look at other countries and you look at their standards, and even HUD, you really should be aiming higher. The bar should be set higher.
Yeah.
55 to 57 really
Right.
should be where you're falling in for a good quality product.
Noise complaints have skyrocketed since the pandemic started, just because people are home all the time. I will add one other element to this, that even beyond code, and this is something Matt and I are seeing more and more in the New York market, is informed buyers. Buyers are asking much more informed questions than we saw 5-10 years ago. Buyers are asking owners, hey, what's the STC rating of these demising walls? What's the impact acoustical rating of this floor ceiling assembly? They're actually asking this. They're hiring owners reps who, if the buyer themselves may not be as tuned into this, certainly their reps are, as they're buying, especially high, upper level luxury, higher end residences. They're actually asking these questions. And so when we're designing these buildings, it's not uncommon for the developer to say, hey, can you provide a memo outlining the acoustical performance of the demising walls and floor ceiling assembly for us? And so we'll write it up, and that will actually be passed along to buyers. So it's actually becoming a marketing feature of buildings beyond just kind of meeting codes and that kind of thing. Mm-hmm. Developers are saying, this is something we want to feature in as we market this building. And I will tell you, developers make that mistake once, they don't make it twice.
Right.
You know, once they've built a building and they start dealing with the noise complaints, they don't want to have to deal with that, you know, anymore. And I will say some of our best clients are ones who have made that mistake once. You know, then they really understand that this is a substantial issue that needs to be addressed in, you know, in any future developments.
There's numbers, but there's a subjective impression too. And we were able to get a sense just being on site, kind of walking the floors and kind of getting a feel for how it felt and how it heard from below. I'll call it our receive rooms. We were quite impressed with the Sophix system. You know, I think it took, if memory serves me correctly, it took a fair amount of heavy walking to really be audible in the space below. So the Sophix seemed to be working beautifully, at least from a subjective perspective. And I think the numbers backed up our observations.
Christian, that's huge. And, you know, we can look at laboratory acoustical ratings all day long, but as acoustical consultants who have been exposed to a wide variety of acoustical products, we are definitely more likely to recommend products that have been field tested and field verified, because in the end, in a laboratory environment, in a controlled environment, you're going to put in your best installers. It's going to be highly inspected. It's going to be the perfect install. But when, you know, GCs are being pushed to get things built faster and faster and faster, you know, there's only so much attention to detail that they can maintain. It's very different from what you can expect in a laboratory environment. So when we're able to see this kind of acoustical performance, even in the field, it gives us so much more confidence as an acoustical consultant to recommend products like this to our clients down the line.
So guys, that was the last video. Now I know I'm going a little bit overboard on the time that we had. I'm going through the end of the presentation, but I thought there was a very cool interview with both Matt and Nate. I think they expressed some really, really important informations there about designing to mid-50s range, 55 to 57, both on STC and on IIC. The fact that there are a lot more informed buyers nowadays more than ever. And also the fact that people are home so much more than ever before. So it makes sense to take a look at acoustics and make sure we're doing something of value here. So just to head towards the end of the presentation, guys, I do want to talk about studies and other assemblies. If you go to the handouts section on the presentation, I think you have maybe some toolbar that you can go to. There's a section called handouts. And in there, you have 2 documents that you can download, which are completely yours. So one is going to be an acoustical guide for mass timber that we did. We call it the Mass Timber Guide. It's a compilation of the very best, or not the very best, but the most interesting tests that we have done throughout the years on mass timber construction with a lot of different types of assemblies. You are more than welcome to download that so you can take a look at it. And also another document that is available for you to download is the actual case study we did on Greene Avenue, which you are more than welcome to download as well. Now, I did not speak about other assemblies involving mass timber because this was a look at 283 Greene Avenue and what we did there. However, there are a lot of other types of assemblies that we have experienced with, that we have tested, and that we are more than happy to share our experiences with you guys. So that being said, there is an upcoming webinar that is going to be happening next week on Tuesday with a really good presenter. His name is Andre. He's a colleague of mine. He will be talking about alternative types of assemblies for mass timber, and it's going to be a super interesting presentation. So if you go to his LinkedIn page, his name is Andre Rieu. You can go right there, you can sign up. If anything, you could just shoot me an email. I'll be more than happy to share you the link so you signed up as well. So recap and takeaways, guys, this is the end of the presentation. Thanks so much for sticking with me all the way through the end. So first of all, just understand that it's all a learning process. Like Ali said, or like pretty much everybody said in this presentation, it's a learning curve and it's a learning process. You need to learn from past mistakes. And if you continue and you learn from those mistakes, you can end up with something that makes a lot of sense, a building that can make a lot of sense in the future projects that are not only going to be great in aesthetics, but that can also be cost effective. 2, design ahead, get your team involved. You will not regret it. Getting your team involved from the early stages can mean moving forward a lot quicker than if you didn't do it otherwise. Work with solutions that understand the needs of mass timber. You know, you cannot just think about what you used to do in concrete buildings and think that you can do the same with mass timber. It is different, it is beautiful, it's particular, but it has its own particular needs. So you need to understand that. You don't need to know all this, you just need to surround yourself with the people that are able to help you and guide you through this process, of course. Now more than ever, we have to deal with informed buyers. People are asking these questions, guys. People are asking, hey, what's the rating on this building? What is the STC rating? What is the IIC rating? If not the buyer, they definitely have a representative that is going to ask these questions, and we need to make sure we have answers to those questions. Also, understand that acoustics is no longer to be hidden. Acoustics can be a marketing feature, whether it's for the sales rep, whether it's something that you're going to have in the sales office of the building. Now more than ever, people are staying at home, people are working from home, and people want to know if they're going to have an environment that is going to be calm and that is going to be adapted to the way that people are living nowadays, which is living from home. And just remember, at the end of the day, better acoustics just equals less frustration. So make sure that you're taking care of the acoustics in your building. So guys, it's been an absolute pleasure to be here with you. Again, my name is Christian Wallace. I love presenting. I love sharing content that hopefully is interesting to you guys. Unfortunately, we don't have time for a Q&A. You know, I'm way overboard right now, but please, please, please do take my email address. It's cwallace@acoustictech.com. Take my phone number, send me an email, shoot me a text, give me a call. If you have any questions or anything that you need to know, I'll be more than happy to help you out and talk to you if I haven't already before. So again, guys, thank you so much for your time. Have an amazing day and hope I see you soon on the next presentation. Take care.